Assalamualaikum and hello everyone. I am Muzakkir Asyraf and two other group members, Nazmi, Razali and Muhammad Furqan Mazlan. We are from 2 BMFG S1K2. In this video, we will explain about questions in assignment part 2, dynamics. For the first questions, the object from part 1 is released from rest and slide down along the smooth ramp as shown in figure 1. This is figure 1. The object is slide down along the smooth ramp. Okay. Given y0 is taken from value in part 1. Assume y0 is equal 1 meter if y0 is equal 0 in part 1. In our part 1, y0 is equal 0. So, in these questions, we assume y0 is equal to 1 meter. y0 is equal to 1 meter. Okay. For the first question, sketch the free body diagram of the object. So here the free body diagram for the object. N is perpendicular with the surface. The force here and the weight here. The weight go down. And for kinetic diagram, we just only have MA. For question 1B, calculate the speed of the object just before it leaves the surface at B. So we know that B is final and A is initial. Okay. So for this question, we need to use equation 1 on here. Yeah, this equation T1 plus U plus T2. T1 is kinetic energy and also T2 kinetic energy. U is work done by all force acting on the particle, on the object. So just replace the T1 with half m VA squared plus m GH is equal half m VB squared. This is VA squared because the initial value here is A. This one VB, velocity of B at here. So we know that here we can cancel out all the m, all the mass. We just cancel out, and then we know that VA here, VA is equal 0 because the object is released from rest. And G is for gravity. H, the value of H is from here. This is H. So we know that y0 is 1 meter. So 3.5 meter minus 1 meter, and then we got H equal to 2.5 meter. Okay, 2.5 meter. So we just put in all the value, and then we got VV is equal 7.0036 milli per second.
We will continue for question 1C. The question is calculate the distance from the wall of the ramp at B to where the object strikes the ground. So we can, from the figure here, we have to calculate the distance of the object from here until the object reach the ground. So we have to calculate the distance from here until here, until the object reach the ground. So we can use this equation, y equal to y naught plus v naught y times t plus half ac t squared. AC, we have to replace it with the gravitational acceleration because the equation is just for y component, so we need to replace AC for gravitational acceleration. From the figure here, we can know the y naught here is 1 meter, so we can assume that the y after the ball reach the ground is equal to -1. So we can replace y here for -1 equal to 0, since the y naught here is 0, plus v naught y 0 times t plus half -9.81 times t squared. So we can get the time here equal to 0.4515 seconds. After that, we can use this equation to calculate the distance from here until here. We can calculate the s here. S equal to S naught plus V naught S T. S equal to S naught is equal to 0 plus VBT. VB equal to 7.0036 times time that we get from here is equal to 0.4515, and we can get the S distance equal to 3.1614 meter. Next, we will continue for question 1D. The question is compute the speed at which the object hits the ground. So we have to calculate the speed when the object hits the ground here. So we can use the principle of work and energy equation, which is T1 plus total U12 equal to T2, where the T1 here is initial kinetic energy, and total U12 is potential energy, and T2 is final kinetic energy. From here we have the formula for kinetic energy is half mv squared v initial squared plus mgh equal to half mv final squared. Since the mass is the same, we can cancel this out, and v initial we can replace it with the v we can replace it VB. Here VB is here. Okay, so we can replace the value into the equation, and we can get the V final, and the V final here equal to 8.2868 meter per second.
For the question 2, the object from part 1 release from rest and slide down along the smooth ramp as shown in figure 2. This figure 2. The note is assume y naught equal to 1 meter if y naught is 0 in part 1. So if in the assignment 1 we got y naught equal to 0, then we use in this question y naught equal to 1 meter.
For the question A, calculate the velocity of the object just after it rebounds from the ground. So we want to calculate this velocity because it's rebounds. So we use this equation for VCY. Then we assume at this place we put 0, we assume, and this -1. So V1y, we know it is equal to 0, then we put here, and 2g minus SC at 0 and SY0 if equal to -1. Okay, then we just put here G, we replace it equal to -9.81, and we calculate, then we got -4.4294. Why negative? Because it show the downward. Okay, then we just replace it with this symbol, downward symbol. Then we want to calculate VCY2. We use this equation. This equation we get from equation 3 in the assignment. Just take in the question at this 0.7. We just replace it, and VG, we replace it to 0. We want to search this. Then VCY we got from this, we calculate just now. Then we calculate, we got 3.1006 upward. Okay. Then we want to search the magnitude. But before that, we have to search for VC for X. We use this equation. Then we calculate this VCX. Then we got this. Then we search the magnitude. We just put square root and kuasa 2. Then we got this. Okay, thank you. For the question B, the question is compute the maximum height to which the object rise after the first bound. So this first bound, and then this second bound. So we want calculate this height for the maximum height at this. So we use the same equation, but the difference is for this. These two value is different. At lower we put 0, and at this we put H for height. And then V2y equal to 0, and then VCY we got at the question A at this, and then we just replace it at this place, and then the G is negative 9.81, and S2y this H, and SCY 0 because at the lower. Then we'll calculate the height. We got 0.49 meter.